Hey guys, Mr. B here, and in this video I'm going to be going over the problems in the distance and displacement quizzes practice. Okay, now I have the problems here in front of me just as words. They're obviously not on the quizzes quiz, but it's because I want to take my time to walk my way through them so that you understand how to solve these problems. Okay, so we're going to start here with number one. It says, Joey drives his ski-doo 7 kilometers north. He stops for lunch, then drives 5 kilometers east. What distance did he cover? What was his displacement? All right, so I'm going to switch over to paper here because usually when we do these problems, it's really good to draw a picture, okay? So I have my camera here, and I'm going to draw a picture here, okay? So first, he's going to drive his ski-doo 7 kilometers north. So let's just draw a line or a vector and label it 7 kilometers going north. Then he drives 5 kilometers east. So we're going to draw another vector, label this 5 kilometers going east. So he starts here and he ends here. Okay. So for his distance, that part's pretty simple. All we're going to do is add together our two vectors. So distance is 7 plus 5, and we will get 12 kilometers for our distance. Okay, that one's easy. Our displacement, right? So that's the tricky part, is what's our displacement? So remember that displacement is from start to finish in a straight line. How far did he go? So let me grab another colored pen here. Okay, so our displacement is this. That line. That's his displacement. We want to know what is that length and, of course, what direction. So to do this, if we look at this, we're going to notice this looks like a triangle. Okay? And so to do this, we can use the Pythagorean Theorem. So we're going to go a squared plus b squared, square root that equals c. And in this case, we'll label this side a, this side b, and this side will be c. And it doesn't actually matter which side is a and which side is b. The one that matters is that the displacement part is always c. Okay? So we're going to plug this into a calculator. So we'll take square root of 7 squared plus 5 squared equals. Okay, so I'm just going to do this on my cell phone. I could pull out a calculator, but cell phone works just fine. So let's go 7 squared plus 5 squared, and then we will square root that. And we're just going to round to one place after the decimal. So I get 8.6 kilometers. And then we need to include direction, and in this case, he went northeast. Okay, so displacement is going to be 8.6 kilometers northeast. Okay, so that is number one. There's our first problem. Okay, let's take a look here at number two. So let's switch back to our worksheet here so we can see what the problem says. Okay, so number two, it says Anthony walks to the pizza place for lunch. He walks 1 kilometer east, then 1 kilometer south, then 1 kilometer east again. What distance did he cover? What was his displacement? All right, so again, let's draw a picture. So first he starts by walking 1 kilometer east. So we'll label this 1 kilometer going east. He then goes 1 kilometer south. So 1 kilometer going south. And then he goes 1 kilometer east again. So 1 kilometer going east. So he ends here. And he starts over here. Okay, so if we draw a picture, this is what it's going to look like. So for our distance, again, distance is pretty simple. We're just going to add our vectors. So 1 plus 1 plus 1. We'll get a total distance of 3 kilometers walked. Okay, again, that part's the easy part. Let's talk about the displacement. That's the trickier part. So for displacement, again, like in the previous problem, our displacement is from start to finish in a straight line. How far did he go? Now we'll notice that this line is a little bit tricky because it kind of cuts through the other vectors we've already drawn. And again, you might be thinking to yourself, how the heck do I solve this, right? This looks really complicated. Well, let's simplify this down. Okay, so we have to remember when we're dealing with vectors, if we have vectors that are in the same direction, we can add them together or combine them, okay? So we'll notice here that we have two vectors that are both going to the east. So we have 1 kilometer east and another 1 kilometer east, right? So if we draw them next to each other, they're going to look like this. 1 kilometer going east, and 1 kilometer going east. We could just, instead of writing two separate vectors as 1 kilometer east, 1 kilometer east, let's just draw this as one vector that's 2 kilometers going east. Okay, so we're taking these and we're turning it into that one vector. As for the 1 kilometer going south, that one we just keep the same because there are no other vectors going south. So we'll just leave it as it is. And now, again, our starting point is over here, and our ending point is down here. And if we draw our displacement line like we did before, this looks like a triangle, just like it did in the previous problem. So from here, we can solve our displacement using the same thing we did before, the Pythagorean Theorem. And we'll have this side as A, this side is B, and the displacement will be C. So we can go square root of 2 squared plus 1 squared equals, and again, we need to square root this, so let's use our calculator and just do this real quick on our calculator. 2 squared plus 1 squared, and then square root, and I get 2.2 kilometers, and then the direction is southeast. Okay, so southeast. And there is our displacement. Okay, piece of cake. So that was a little bit trickier because we had to kind of simplify down our drawing, but once we simplify it, it basically turned into the same kind of thing that our first one did, where we just had a triangle, we just went from there. Okay, let's take a look at problem number 3. So it says, on his fishing trip, Justin takes the boat 12 kilometers south. The fish aren't biting, so he goes 4 kilometers west. He follows a school of fish 1 kilometer north. What distance did he cover? What was his displacement? All right, so let's take a look back at our paper. And again, let's draw this out. So first he goes 12 kilometers south. Okay, so we're going to draw a vector. 12 kilometers south. Sorry, it's a little bit shaky there. Then he goes 4 kilometers west. So 4 kilometers going west. And then he goes 1 kilometer north. And he goes up 1 kilometer. I kind of drew that in the wrong place, but that's okay. 1 kilometer north. Okay, so he ends here, and he starts there. Okay, so this is kind of what his little trip looks like. So he goes south 12, west 4, and then he goes up or north 1 kilometer. All right, so what was his distance? So try pausing the video and solving this one real quick, and then you can hit play and see if you got it right. So for distance, we're just going to add our displacements together, our distances together. So we have 12 plus 4 plus 1. So 12 plus 4 is 16, plus 1 is 17 kilometers. So there's our distance. No big deal, piece of cake. As for our displacement, again, this is the tricky one. We'll notice that if we draw a line, again, from start to finish, this red line, it's kind of difficult, right? It looks hard. But remember, we can always simplify. So like in number 2, we had 2 vectors that were in the same direction, and we added them together to give us one bigger vector. In this one, we have 2 vectors that are in opposite directions. We have 12 kilometers south and 1 kilometer north. So if we redraw this, okay, so let's go, again, we have 12 kilometers going south, and we have 1 kilometer going north. These are opposite directions. So in the previous one, we had 2 that were in similar directions, so we added them together, we combined them. Now we have 2 in opposite directions, so rather than combining, we're going to subtract them. Okay, so 12 kilometers minus 1 kilometer. If we take these, we can simplify this down into 11 kilometers going south. Okay, 12 minus 1, and because this vector was the bigger of the 2, our resultant vector is still going to be 11 kilometers. And then, of course, we have our 4 kilometers going west still. So we have 4 kilometers going west, and there is no other vectors going west or east, so that's it. So it means here's our ending spot. Here's our starting spot. And again, our displacement is this red line. And if we look at this now, we'll notice this looks like a triangle, just like this one looked and just like this one looked. And so from here, all we're going to do is use the Pythagorean Theorem, just like we did in the previous ones. So we can label this side as A, we can label this side as B, and again, our displacement is C. And it doesn't matter, again, if you wanted to go this one is A and this one is B, or, you know, switch them around. As long as the displacement is C, that's all that matters. So let's go square root of 11 squared plus 4 squared equals, and again, I will do this on my phone and my calculator here. So let's go 11 squared plus 4 squared, and then square root this. We get 11.7, I believe. Let me just double check this. 11.7 kilometers. And our direction is going to be southwest. Okay, so 11.7 kilometers going southwest. That is our answer. Okay, so hopefully that gives you some clarity on how to do these problems. But as always, if you have any other questions, make sure you let me know. Either email me, you can talk to me in class, or we could do a Google meeting or something. Just make sure that you get your questions answered. All right, guys, that's it for this one. Hopefully that helps. See you in the next one. Bye.